I've taken signal x of n with 4 samples 0, 1, 2, 3. So this is the signal which will have the sampling rate of fx, let's say. Let us consider I equal to 3. So we will make this waveform with the assumption that interpolation factor is equal to 3. So let's see how the waveform y of n will look like. In the waveform y of n, I will first obviously choose the original sample, which is sample at 0. So I choose that in y of n as it is. But later on, because I is equal to 3, for every sample of x of n, I need 3 samples in y of n. So let me quickly name the samples as S1, S2, S3 and S4. S1 will come here as it is. Now before we read S2, I'll have to insert 2 zeros. So whatever is the value of I, we have to insert number of zeros which will be equal to I minus 1. So there'll be 1 0 here, 1 0 here. This will be the values of n which will be equal to 1 and 2. So when I take n equal to 3, I will read the second sample from x of n. The second sample from x of n will be nothing but S2. Now after I read S2, now again before I go ahead, I'll have to insert 2 zeros. So 2 zeros will be inserted at n equal to 4 and n equal to 5. So when I take the point n equal to 6, I'll read the next sample from x of n, which was named as S3. So I read S3 now, which will come at n equal to 6. After S3, we will have to insert 2 more zeros and then read S4. So S4 will appear at n equal to 9 because n equal to 7 and 8 were 2 more zeros inserted. And this process will continue. This is my S4. I will again insert 2 more zeros and I will read the next sample at n equal to 12. So this process will continue, and this is how we will convert x of n to y of n. The new signal y of n will definitely have sampling rate equal to fy, and you can see in this case fy will be equal to 3 times fx. For every one sample, you have got 3 new samples. So now, even though the names in the signal y of n are S1, S2, S3, please remember that this is not the second sample. The second sample is the 0 sample. So what I'll do is I'll just call this as S2 dash, S2 double dash. This will be S3 dash, S3 double dash. These are all new samples that we have inserted, S4 dash, S4 double dash, and so on. So if you want new naming for all these samples, the S1 remains S1, S2 dash becomes S2, this becomes S3, and S2 will become S4, this will become S5, this is S6, this is S7, and S8, S9, so S4 will be S10, and so on. So this is the process of interpolation. These are the waveform. That's very simple. All you have to do is insert new zeros. It is nothing but exactly same as the scaling process that we had done before. You can see my original signal x of n expands, and it expands by the factor of 3. So that can simply be written as x of n divided by 3. So when I write x of n by 3, that means I have to multiply the time axis by 3. So the sample of 0 goes to 0, sample at 1 goes to 1 into 3 at 3, sample at 2 goes to 6, sample at 3 goes to 9, and in between we insert 0 samples because we have got new values of n created. So in general, instead of this 3, we will have this, because this example was written for I equal to 3. In general, instead of this 3, we will write x of n by I. So this is the relationship that we get between y of n and x of n. So based on this relationship, we will now go through the mathematical derivation in which we will be able to study the frequency spectrum of this new signal y of n in the form of x of n.